Right, so I have shared my whiteboard. Okay, you would be able to see that in a bit. So today we'll talk about the 27th chapter, that is coordinate geometry. Okay, now in coordinate geometry, we have different types of things and it is easy. It's all about formulas and understanding. So let's get started. It is the 27th chapter, coordinate geometry. Okay, now first you need to understand a few things. That let's say if I make the y-axis and then this is the x-axis, I'll just label the axis. So let's say it's 1, this one is 2, and we have 3, 4, 5, 6. This is 1, 2, 3, 4, 5. Then we have -1, -2, -3, -4, and we have -1, -2, -3, and so on. This is the x-axis, this is the y-axis. Now this is the positive y-axis, this is the negative y-axis, this is the positive x-axis, and this is the negative x-axis, right? We know these details already. Okay. Now, if I talk about a few points, let's say 4, 3, and another point, let's say -2, 2, and last point, let's say -3 and -4. Let's see where exactly these points lie in the XY plane. Okay, so we call this the XY plane. It's just a name. And we have 4, 3. So 4 is the X coordinate and 3 is the Y coordinate. So where is X equals 3? X equals 3 is here. So it would be somewhere on this dotted line. And the other point is, sorry, it is X equals 4, okay? So it is going to be somewhere on this line, and Y is 3. So it would be somewhere on this line. And where exactly is the point? This is the point, right? So these are the basics. This is point P. This is how we define any point in the XY plane. Let's talk about another example. This time we have -2 and 2. So X is -2. And Y is 2. So this time the point is this point, point Q. And if I talk about the last one, that is R. So it would be -3, that is the X coordinate is -3. So I'll make a dotted line. It could be over here, it could be over there, anywhere, I'm not sure. Let's see. And the Y coordinate is -4. So what does that mean? It means that this is the line. So this would be the point. And this is R, okay? So the first concept of this chapter is seeing the points on the XY plane. I have shown you 3 examples for P, Q, and R. We know that for any point, we have dash, comma, dash. The first one tells the X coordinate, the second one tells the Y coordinate. If I take another example, let's say 2 and -3, I will follow the line X equals 2. So let me just make a line this time on X equals 2. Now the point could be anywhere on this line, and for X equals -3, I'll make another line. That is this one. So I have the point on this intersection, that is S. right? So this is how we define points in the XY plane. So Saneem, you just joined. Did you understand this concept?
Oh, yes, ma'am.
Okay, good. Right. Okay. Now, basically, other than this, if I talk about this chapter formally, I would like to talk about the four most important things which we will discuss in this chapter. The first one is the distance between 2 points. Then we'll see how to calculate the gradient or the slope of any line. Then the midpoint of any 2 points and the equation of a straight line. So let's keep one thing at a time. Let's talk about how to find distance between okay, let's see how to find distance between 2 points. Okay, so again we have a fixed formula. Let's say I will make the xy axis again. This is the y-axis, then this is the x-axis. I'll just label 2 points. Let's say this point, that's its coordinate is 1, this is 2, and then maybe this one, this is 3, and then this is 1 and this point. Okay, so I am interested in finding out the distance between these 2 points, let's say A and B. So first let's see what exactly distance means. Distance means this length, the length between these 2 points A, B. Okay, I'll make a straight line and I need to find the length of this line. Obviously, the length of this line and the distance between these 2 points is the same thing, right? So the formula is, I'll write down the general formula. So distance between two lines AB is equal to under the root, then we do x2 minus x1 square plus y2 minus y1 square. Okay, this is the formula which you would be using every time when you have been asked to find distance between 2 points. Any confusions?
No.
Okay, good. Turhan, are you okay with it?
Yes, ma'am.
Okay, now obviously we need to see how to use this formula. So let's talk about this as the very first example. Example number 1. Now this time around I have a demonstration as well. Every time it's not necessary that they give you the diagram. Obviously they'll just give you the 2 points and they would expect you to find the distance between those 2 points. Okay, so this time around the x coordinate is 1, the y coordinate is 2 of the first point, and the second point has 3, 1. These are my coordinates. Okay, I will use the formula AB equals under root. Now, what is x2 and what is x1, what is y2 and what is y1? It is completely your choice. You can think about any point as the first point and any point as the second point. Okay, so I'll think about this as the first point. If this is the first point, 1 would be x1, 2 would be y2. If this is the second point, obviously this would be the x2 and y2, right? So x2 minus x1, the difference of two x coordinates, that is it. You are squaring it up, you would get the correct answer. Okay, even if you take 1, even if you take 3. So 3 minus 1 square plus y2 minus y1. So it would be 1 minus 2 squared, and that is going to give us under the root 2 squared plus minus 1 squared, and that would be under root 5. So this is how we calculate the distance between 2 points. Any confusions?
No, ma'am, it's clear.
Okay. Let's talk about another thing now. Okay. let's talk about, we are done with the distance between 2 points. So this is the concept, that is it. Let's talk about the second concept, that is gradient. Now, how do we calculate gradient? Okay, now this is the second concept of this chapter. In order to calculate gradient, again, we need a formula. Once we have the formula, we can easily find the gradient of any line, right? First thing is, what do we understand by gradient? Gradient is just the slope of any line, that is it, okay? So I can write it as gradient slash slope. Let's see, how do we calculate the slope of any line? Again, I will make the y-axis. This is the x-axis. And I have a line, let's say this line, and I am interested in calculating its slope. By slope, it means that how steep it is, right? So I need any 2 points on this line. It could be this point, it could be this point, it could be the midpoint and the last point, the midpoint and the first point, any 2 points, right? So let's say I have this point and I have this point, and this point has the coordinates 3, 5, and the next one has 7 and 11. Okay, so again, this is point A, point B. We have a fixed formula and we can easily find the gradient. Okay, so gradient is equal to y2 minus y1 divided by x2 minus x1. What is y2? This is y2 and this is y1. Again, this is your choice. You can think about it other way around as well, okay? So let's just think about it other way around. Let's say this is the first point and this one is the second point. So this means that y2 is 5 minus 11 divided by 3 minus 7, and that is going to give you minus 6 divided by minus 4, and this is 3 by 2. Anything that you have not understood, Turhan and Saneem?
No, ma'am.
No, ma'am, I understand.
Okay, now this isn't it. Yes, that is pretty much about the formula and everything, but we need to understand 4 types, okay? Now I'll make 4 lines. This is the first line. It is a horizontal line. Then this is another line. It's going upwards. Then another line, it's coming downwards. And then a straight line that is parallel to the y-axis, okay? Let's see what exactly is happening in all these 4 cases. Now, obviously, you don't necessarily have to find the slope for all these lines, right? Okay, so for any line that is horizontal, that is parallel to the x-axis, we should know that m equals 0 because it is a horizontal line, right? Then if I talk about the second case, this is the first case, this is the second one. This line is going upwards. Its slope is increasing, okay? So this is going to have a slope that is positive. It is greater than 0, okay? The slope would be greater than 0. And m is just a notation for writing down the slope, right? Then if I talk about the third case, I have a vertical line. In case of this vertical line, what do I see? It means that the slope is what? The slope is infinity, right? Infinity is the world's biggest number. We don't know what it is, but it is the world's biggest number, right? So this is the slope in this case. And if we have a slope that is coming downwards, that is the fourth case. So that would be less than 0, right? Did you understand this? All of you, both of you?
Yes, ma'am.
Okay.
Yes.
All right. Okay. Now I would like to demonstrate this using an example. Let's just quickly talk about an example. Let's say this is the y-axis. This is the x-axis. I will make a line joining 2 points. Let's say this point has the coordinates 1 and 4, and then I have another line and it is 3 and let's say 1. Okay, now I'll connect these two lines, and what do we see? We see that it is coming downwards. Okay, so according to the theory, the slope should be negative. So m is y2 minus y1 divided by x2 minus x1. How do we calculate the slope? This is the formula. And if I plug in the values, what do I get? 3, 1 and 1, 4. So m is going to be y2 could be any coordinate. Let's just pick this as the second point and this as the first one. So it would be 1 minus 4 divided by 3 minus 1. And what do we get? We get minus 3 by 2, and look, it is negative. This is what the theory was telling us, that any line that's coming downwards would have a negative slope. So this is the concept, right? Again, we will stick to the same thing, gradients and slope. Let's talk about another concept about this. So I'll just do it quickly. Now, we need to know that we have two cases. Okay, yes, we can have multiple cases, but we have two important cases, and this time around we have two lines. This is a line, and then I will draw another line that is parallel to the first line. Now these two lines, I label them. Let's say this is L1 and this one is L2. I have two lines that are parallel to each other. In that case, it could be that there's a diagram in which it looks like they're parallel, but if they're parallel, they are going to tell you in the question certainly, right? Okay, if two lines are parallel, let's say this line has slope m1 and this line has slope m2. M1 would be equal to M2. That is the first concept about lines, right? Did you understand this?
Yes.
Turhan, are you okay with this?
Yes.
All right.
Yes.
Okay. And now let's say I have a line. This is the line. And then I have another line. Let's say this one. Now these two lines are perpendicular to each other. It could be that the other line is somewhere here. It could be that it is here. It could be anywhere. The only thing which you need to understand is that both these lines are perpendicular. So if two lines are perpendicular, the angle between them is going to be right angle, right? Okay. So let's say, let's just pick up two lines. I'll just rub these two other lines. Okay. So this is L1 and this is L2, and they are perpendicular. The rule says that, let's say this line has slope m1 and this line has slope m2. m1 multiplied by m2 is -1. This is the second concept, right? So if I have two lines that are parallel to each other, their slopes would be same, this one. And if I have two lines that are perpendicular to each other, the product of the slopes is going to give me -1, right? Yes, Saneem and Turhan?
Yes,
Yes,
ma'am.
ma'am.
Okay. All right. That is good. Okay. Right. Another thing is related to two perpendicular lines. Do you guys know what exactly is a perpendicular bisector? Or maybe let's talk about the midpoint and then we'll talk about this. Okay. All right. Now, let's talk about the next concept, that is midpoint. Okay. So this is the third most important thing of this chapter. Midpoint. Midpoint could be a point between 2 points. Midpoint could be the midpoint of a line. That totally depends on question. So it is basically the exact half of a line, okay? When we say midpoint, it is the exact half of a line. Now, how do we calculate midpoint? That is the thing, okay? Let's say I have a line of this type and it has 2 points. This point is P, the first point is A, and point A has coordinates x1, y1. Point B has coordinates x2 and y2. In order to calculate the midpoint, we do it this way. So midpoint of AB is going to be again a point because it has a word point. Every point has two coordinates. So I would have x coordinate and y coordinate, right? Let's see what exactly happens in x and y. How do we calculate half? This is how we do it, okay? x1 plus x2 divided by 2, and then y1 plus y2 divided by 2. This is the formula which we use in order to find the midpoint of any 2 points, right? So let's talk about an example. I want you guys to do it. This is example number 1 in case of midpoints. Let's say I have a line. It is of this type. No, not exactly this type. Let's make it a different one. Let's say it is of this type. And this coordinate is 1 and 2, and this coordinate is 7 and 4. Okay, so I want you guys to find the coordinates of the midpoint that would be somewhere here. Okay, so I want the two coordinates from both of you. Yes, Turhan, are you done? Saneem told me the answer. It looks like it's correct. Please share your please share your answer with me. I want you to try as well.
Okay, ma'am, just sending it in chat 1 second. I sent it.
Okay, very good. So basically we need to add the x coordinates, divide by 2, and then y coordinates, divide by 2, and the answer would be 4 by 3. Very good, both of you. That's correct. Okay. Now we know what exactly is midpoint, right? Midpoint is the central point. So can I say that this length and this length, they are same? Yes, they certainly would be same, because midpoint is the exact half of a line, right? So this and this, these lengths are same. This is what a midpoint is. Okay, now since we have discussed the relationship of slopes in case of two perpendicular lines, and we have also seen what midpoint is, so let's talk about another concept, that is perpendicular bisector. Okay, it is self-explanatory. Everything is written. We have everything in the word. Okay, perpendicular bisector of a line. I'll make a line. Let's say this is a line, and I want to find, or I want to see, how would its perpendicular bisector look like. Okay, so I'll make that quickly. The perpendicular bisector of any line is a line that is perpendicular to the line, not only perpendicular, but it cuts the original line in exactly two halves, right? So the concept is that the yellow line is the perpendicular bisector of the black line. So it would be perpendicular, and this length, they are same, right? So what two things do we know about a perpendicular bisector? That, let's say the slope, this is line 1 and this is line 2. So we know that if I talk about line 2, I'm interested in the perpendicular bisector, because the yellow line is the perpendicular bisector of the black line. Okay, this is important. We are only interested in the yellow line. Okay, now what exactly do we know? L1 has slope m1 and L2 has slope what? I'll tell you. We know that in case of two perpendicular lines, when I multiply their slopes, I am going to get -1, right? So I am interested in finding out the slope of M2, and I know that the slope of M1 is M1. So I can say that M2 has a slope that is equal to -1 by M1. Now in exam, if you have been asked to find the slope of a perpendicular bisector and you know the slope of L1, you can use this formula and find the slope of M2 directly. First thing. The second thing is that you know a point that is lying on L2, and that point is this point. Basically, you would be given the two endpoints of L1. So using the midpoint formula, you would be able to calculate this. The midpoint of the black line is lying on the yellow line as well. It is not necessarily the midpoint of the yellow line. It could be any point, but that point is on the line 2, right? So you should know that in case of a perpendicular bisector, you can calculate its midpoint and its slope as well. Right, guys? Are you okay with this?
Yes, ma'am.
Okay. Let's see an example. This is the y-axis. Here I have, or maybe I can directly just make a line. There's no point in doing it that way. So let's say I have a line of this type. Okay. I'll just write down the two endpoints of this line. So this point is 1 and 8, and this point, the last point of the line is, let's say, it is 5 and it is 1. Okay, so these are the two coordinates of the endpoints. Let's say this is A and this is B. My question is find the slope and a point lying on the perpendicular bisector. Find the slope and a point lying on the perpendicular bisector of AB. So you have 5 minutes, think about it and tell me your answers. And if you are not able to do it, just tell me directly, I will do it for you, okay? Not an issue. Okay, right, okay. Good, both of you, very good, excellent. All right, now what have you done exactly? For finding the slope of the perpendicular bisector, you have just messed up something that I'll tell you what. Basically, my question is not related to this line. Okay, we have this line. Yeah, my question is about the perpendicular bisector of this line. So you have done half things correct, but I'll tell you what things are wrong. Okay, perpendicular bisector is a line of this type that is going to bisect the green line. By bisect, I mean it is going to divide it into exactly two parts, right? So this would be the line, the blue line. It would be perpendicular and these two lengths are same. So first question was to find the slope of the perpendicular bisector. I told you the relationship of slopes in case of two perpendicular lines. Let's say it is L1, this is L2. So M1 multiplied by M2 equals -1. We can calculate the slope of M1. That is correct. You guys have done it correctly. It would be minus 1.75. Okay, Turhan? It is coming downwards, so the sign would be negative. You messed up with the sign, but other than that, it is correct. Multiplied by M2, we don't know. We need to find that. We can easily find that. So M2 is going to be -1 divided by 1.75, like minus 1.75, and that is going to be 4 by 7 basically. So Saneem said that the answer is -7 by 4. Yes, -7 by 4 for the line AB. But for the perpendicular line, it would be the negative reciprocal of -7 by 4. Negative reciprocal of -7 by 4 is 4 by 7. Okay. So the slope is 4 by 7. It is not minus 1.75. Minus 1.75 is the slope of the line AB, not the blue line. The question was about the perpendicular bisector. Okay, be very careful with the wordings. And the second part was, and a point lying on the perpendicular bisector. So I told you before this question that this is the point which we can calculate. That would be the midpoint of AB. Since the perpendicular bisector is bisecting the line AB, it would cross the line AB, it would intersect the line AB at the midpoint of line AB. So for that, you need to find the midpoint, okay? So midpoint is going to be midpoint of AB. It would be 3, 4.5, right? So these are the two answers which I wanted from you guys. So some part of the answer was correct, but not all the part, right? Okay, I'll give you another example. Again, the question is going to be similar. I want you to do your workings for the perpendicular bisector when I will give you the line only. So let's say we have a line of this type, and I'll tell you a few things. So this point has it has 8 and 9, and then this point has 1 and let's say 2. Okay, and I'll tell you that the slope of the black line is, this is A, and this is B, and this is L1. So you have been told that L1 has a slope. Just give me 1 second. I need to calculate that first. 7 by 1. Yeah. The slope is 1. Yep. Okay. So it should be M1 basically, not L1. M1 is 1. M1 is 1. Okay. Now I want you guys to do the same question. Find the slope of the perpendicular bisector and a point lying on it. And you just need a minute or so because I've done half the calculations for you guys. Good, Turhan. And what about the slope of the perpendicular bisector? Well done, Saneem, and very good, Turhan. Okay, so both of you have calculated the point correctly. Yes, you guys are right that the point lying on the perpendicular bisector would be the midpoint of AB. So if I make the perpendicular bisector, it would be something of this type, and it would have the 90 degrees angle because obviously they are perpendicular. And this is the point lying on yellow line as well. That is the midpoint of AB, and that is 4.5 and 5.5. That is good. For the slope of the yellow line, you need to understand the concept that if this is L2, these two lines are perpendicular, so their slopes would multiply and give you -1. You know the slope of M1, that is 1. You need to find the slope of M2. You can easily find it by making M2 the subject, and M2 is -1, right? This means that the slope of perpendicular bisector is -1 and the midpoint is 4.5 and 5.5, right? So Turhan, did you understand this now?
Yes.
All right, okay. Okay, now tomorrow we'll talk about the equation of a straight line, how to write that, different types of that, and yeah, okay. And we'll also do some past paper questions if we get time, otherwise we'll do those on Monday. Okay, so that is it. Then I'll see you tomorrow, inshallah. Take care. Allah Hafiz.
Allah Hafiz.
Allah Hafiz.
Allah Hafiz.